Our work is entitled English Intermediate Task Training Improves Zero-Shot Cross-Lingual Transfer Tool. This work is by myself and Yasser, as well as many other collaborators at NYU and CU Boulder. Here is a quick summary of our paper. We find that training multilingual models, such as XLMR, on an English intermediate task can improve model performance even in scenarios of zero-shot cross-lingual transfer. Moreover, we find that the strongest gains are on sentence retrieval target tasks. These are tasks that have no training data, so the only fine-tuning being done will be on the intermediate tasks, if any. To start, let's do a quick recap of zero-shot cross-lingual transfer. Many of us are familiar with regular fine-tuning. That's where we take a pre-trained encoder such as BERT, we fine-tune it on some training data for a given task to obtain a tuned encoder, and then we evaluate the tuned encoder on validation or test data for that given task. Zero-shot cross-lingual transfer is similar. In this case, we start with a multilingual encoder. That's an encoder that's been pre-trained on text from many different languages, for instance, MBERT or XLM. We fine-tune this encoder on training data for a given task in one language, for instance English, to obtain the tuned encoder weights, and then we evaluate that encoder on test data but in a different language, for instance Chinese. So if you think about it, the encoder has been exposed to data from many different languages but has never seen task data in Chinese, so it's zero-shot with reference to it. Now, suppose you have data from another task which you think might be useful to train your model on in order to improve performance on the target task, the task that you really care about. Here's a really simple recipe for transfer learning. As before, you start with your encoder, and what we're going to do is we first fine-tune the model on this intermediate task, this extra task that you have, in order to get intermediate tuned encoder weights, and then we fine-tune the model on the target task training data to get this final model that we then evaluate on the target task's validation or test data. So this is the simplest possible transfer learning format. All you're doing is fine-tuning the model twice, first on the intermediate task and then on the target task. And surprisingly, this works. We've found that this can improve performance in many cases, the most common example being the glue benchmark. It is now common practice to first fine-tune a given model on MNLI and then on RTE in order to improve RTE performance. Granted, this is a really simple method, so there's no mitigation or catastrophic forgetting, there's no task weighting, it's just fine-tuning twice. And moreover, intermediate task selection can be difficult. It's hard to predict what tasks will help or hurt performance, but it's also easy to just try multiple. You just fine-tune your encoder on different intermediate tasks and then on the target task to see if it helps or hurts. So let's combine the two, intermediate task training and zero-shot cross-lingual transfer. In this case, we're going to start with a multilingual encoder. This is a text encoder that's been trained on text from many different languages. We're first going to fine-tune it on English intermediate task training data to get this intermediate encoder, and then we're going to fine-tune it on English target task training data to get our final model. We can then evaluate this model on the same task data in many different languages, for example Chinese. So it's still zero-shot with reference to the final target task. And the question is, can we find intermediate tasks that will still help in the zero-shot evaluation context? To evaluate on zero-shot cross-lingual transfer, we are going to use the XTREME Benchmark. So the XTREME Benchmark consists of 9 different tasks covering over 40 different languages. And we will specifically focus on the zero-shot cross-lingual format, so we will only be training on the English training data. The 9 tasks can be categorized into 4 categories: 2 classification tasks, 2 tagging tasks, 3 question answering tasks, and 2 retrieval tasks. For the retrieval tasks, they do not have any training data, so they will only be evaluated based on the hidden representations from within the pre-trained model. For our experimental setup, we are going to use XLM Roberta Large as our pre-trained model. XLMR Large has been trained on text coming from 100 different languages. And for our intermediate tasks, we are going to use the following: MNLI, which is a natural language inference task, ANLI or adversarial NLI, which is another natural language inference task that is a superset of MNLI. QQP, which is a sentence similarity task. Squad V1 and V2, which are question answering tasks. HelloSwag, Cosmos QA, and Common Sense QA, which are 3 multiple choice tasks. And CCG, which is a tagging task. Altogether, this gives us a fairly diverse set of task formats for our intermediate tasks. So let's go into the results. Across the rows, you will see the different intermediate tasks that we do intermediate task training on, as well as the baseline row at the top, which is no intermediate task training. And across the columns, you will see the 9 extreme tasks, as well as the average column at the end. Each of the numbers that we report will be the average over a zero-shot evaluation across all the available languages. First, let's take a look at our 2 retrieval tasks. For our both retrieval tasks, we find that intermediate task training greatly improves performance, with over double-digit gains across every intermediate task we try. One explanation for this might be that XLMR does not have a sentence similarity pre-training objective. This is in contrast to BERT, which has mass language modeling and a next sentence prediction objective. So this might suggest that the intermediate tasks are sort of inducing the model to better aggregate information from across the sequence and capture it within its hidden representations, leading to better performance on these retrieval tasks, which aren't further fine-tuned on. Next, let's look at our 3 question answering tasks. In this case, we see more mixed results, but generally still see improvements from intermediate task training from Squad V1 and Squad V2 intermediate tasks. What's interesting here is that XSquad and MLQA both use Squad V1 as their target task training data as well. So what this likely implies is that these 2 models are likely undertuned on Squad V1 training. On the other hand, we see large improvements for TIDQA on intermediate task training for Squad V1 and Squad V2, over a 10-point gain in both cases. Next, let's look at our 2 tagging tasks. Here the results are a little bit more negative. We don't find many cases of positive transfer on top of our baseline. What's also interesting here is that CCG is our only tagging-based intermediate task, and it leads to negative transfer for both of our tagging target tasks. Finally, let's take a look at our 2 classification target tasks. For XNLI, we do not see any improvements from any of our intermediate tasks. XNLI has a fairly large training set, which is actually MNLI, and we do not see any improvements from MNLI either. On the other hand, for POSX, we do see improvements from 4 intermediate tasks: MNLI, Squad V1 and V2, and HelloSwag. One thing that's notable here is that although ANLI is a superset of MNLI, we do not see that it has better performance than using MNLI as an intermediate task. One additional thing we tried was to do multitask training across all of our intermediate tasks. Unfortunately, the results aren't super interesting. They generally look like the average of the single intermediate task model results. But if you look at the column on the right, which takes the average across all of the target tasks, we find that the multitask model actually performs best overall. But there is something potentially concerning about our experimental setup so far. If you recall our full experimental pipeline with intermediate and target task training, you will notice that there are 2 phases of fine-tuning on English data in between the multilingual pre-training and evaluation on potentially non-English data. One might reasonably be concerned about catastrophic forgetting of our multilingual knowledge from pre-training. So one potential solution to this is that we continue the XLMR pre-training objective alongside our intermediate task fine-tuning. Concretely, this means that we are going to do intermediate task fine-tuning multitasked with mass language modeling on a multilingual corpus. Here we see the results of doing masked language modeling alongside intermediate task training. Overall, the results aren't terribly exciting. Intermediate task training with MLM reduces both positive and negative transfer, in some sense pulling it towards the baseline's results. This makes sense since all we're doing is adding the original pre-training objective alongside our intermediate tasks, so it looks a little bit more similar to the baseline model. So we made a submission to the XTREME leaderboard, and the way that we did this is that we chose the best intermediate task configuration for each of the 9 XTREME tasks based on the validation set performance and the generated test set predictions based on those. You'll find our submission over here, where we comfortably outperform the XLM Roberta large baseline. You will, however, notice that a couple of other submissions have outperformed ours since. One thing to note though is that our submission was based on the zero-shot cross-lingual format, where we only train on the English target task data, whereas a number of these other submissions use a slightly different format called Translate Train or Translate Train All, where they do make use of target task data from other languages. I know that entries 2 and 3 are based on the Translate Train and Translate Train All formats. I'm not super sure about entry number 1. But just a quick summary for anyone interested. Filter is a method that is inherently based on inputs of multiple languages, and VICO, both entries 2 and entry 1, are based on freshly pre-trained models. With all our results in hand, one might reasonably ask, why does this work at all? Why are our models still able to perform well even with 2 phases of fine-tuning on English in between? Well, one way to think about it is that adding an additional phase of fine-tuning with an intermediate task is simply extending the fine-tuning stage on English data. In some sense, if we already have results from XLM and MBERT showing that zero-shot cross-lingual transfer works when you just fine-tune on English and extrapolate to other languages, then extending that phase with intermediate task data shouldn't hurt, and if you pick the right intermediate task, it might even improve results. And moreover, this should extend to other transfer learning methods as well, and we should really expect potentially more sophisticated transfer learning methods to perform even better than what we've tried. Another thing that we considered is, what if we didn't use English intermediate task data? Suppose that instead of intermediate task training on English, we did it on data in another language. So starting with our pipeline, we might fine-tune it on, for instance, German intermediate task data. We will still do target task training in English, but we might do validation on German again. In other words, we want to do this intermediate task training and target task evaluation with the same language. How might this affect the per language task performance? Now, one caveat is that for this experiment, we're going to do this with machine translated intermediate task data, so keep that in mind. The full results of our experiments can be found in our paper, but here's a quick summary. The results are a little bit more mixed. We do see some improvement from using the same language for both the intermediate task as well as the evaluation task for tie-dye QA, XSQuad, and NER, and we do still see large improvements for retrieval tasks as before. But we found that in many cases, using English intermediate task data works just as well as using translated intermediate task data, so the picture's a little bit fuzzy. One thing to note is that we are using translated intermediate task data, so the quality of the translations may significantly affect results, so do take them with a grain of salt. Okay, so to wrap up, we've shown that intermediate task training, a very simple transfer learning method using English intermediate task data, can improve performance even in a zero-shot cross-lingual transfer scenario. On the other hand, the benefit of using English versus target language specific intermediate task data is still a little bit less certain. This still leaves us with the following question. Why does it seem that catastrophic forgetting of knowledge of other languages after fine-tuning on English doesn't seem to be a big problem for multilingual encoders? This is something that we hope the field will be able to answer in the near future. One final plug before we go, our team at NYU has been building Giant, a research toolkit for transfer learning at NLU, and it supports XTREME, including generating submission files for the leaderboard. And all the experiments in this paper were run using this library, and it's compatible with Hugging Face's transformers as well. If you want to check it out, go to this URL, giant.info/xstilts. Thank you very much for coming to our presentation.